All right, everybody, welcome to Math with Grace. Today we're going to be going through Math 7, Book 709, Lessons 11 through 15. Lesson 11 begins on page 44, and it's titled Metric and U.S. Measures of Land Area. So, some more conversions for us. It says the basic metric unit of land measure is the hectare. A hectare equals 10,000 square meters. A square of land that measures 100 meters on each side is a hectare, okay? So a square that measures 100 meters on both sides. Larger areas of land are measured by the square kilometer. There are 100 hectares in a square kilometer, okay? The basic U.S. unit of measure is the acre. An acre equals 43,560 square feet. An acre of land that is square measures about 209 feet on a side. So if you had a square acre, okay, it'd be about 209 feet by 209 feet, right? Large areas of farm and ranch land are measured in sections. A section is 1 square mile of land, which equals 640 acres. A half section is 320 acres, and a quarter section 160 acres. That being said, here are the ones that they're going to concentrate on, okay? 1 acre is 0.4 hectares. 1 hectare is about 2.5 acres. Okay, let's take a look at our homework part. Okay, use a ruler to complete the scale drawing of a square mile. The scale is 2 inches equals 1 mile, okay? And complete the sentences. All right, the first instructions read, divide the square mile in half with a horizontal line this way. So grabbing my trusty ruler here, remember it says 2 inches. Let's just double check. Yes, it is. So to divide it here, I'm going to mark the 1 inch. And the 1 inch, you can see I'm just lining up the top and the bottom of my square with the 1 and the 2 inch, or the 0, sorry, and the 2. And so there we go. We have divided it in half. Now, how many acres does this half section contain? Well, remember, 1 square mile is 640 acres. So this was 1 square mile originally. We cut it in half. So we have half of 640 acres, right? So 640 divided by 2 is how much? How many 2's go into 640? Well, there's 3 2's in 6. There are 2 2's in 4, and there are 0 2's in 0. So it's 320 acres. All right, now it says divide the top half of the section in half again with a vertical line. Okay, so remember, it's still 2 inches wide this way. So we want to divide it in half. So we're going to mark the 1 inch spot. So we just want to divide the top portion in half, okay? And it says each quarter section contains how many acres? Okay, we read all this, right? A quarter section is 160 acres. And measures how many miles on each side? Well, it's a half of a mile by a half of a mile. So 1/2 mile, you could put 0.5 if you wanted to. 1/2 mile on each side. Oops, running out of space. I guess I'm on the thing. Okay, divide the top left quarter section into 4 equal plots using 1 vertical and 1 horizontal line. Okay. The top left is this section here. Remember, it's now 1 inch by 1 inch, and so we're going to divide it into the halvesies, right? I'll do the vertical first and then the horizontal. So here is this halvesies, and then we are going to go this way. I got to mark my lines first. Halvesies. And this may not be exactly, but because I am sitting off to the side, so my face and my head doesn't get in a shot, that might be a little crooked, but that's okay. Now we have 4 equal plots. Okay. Each plot contains how many acres? All right, so, this is supposed to be 160 right there, not 16. Okay, remember, a quarter section, this section here, this whole entire section was 160 acres. We've divided it into 4 parts. So 160 divided by 4 is how much? Okay, how many 4s go into 16? There are 4 4s in 16 and 0 4s and 0. So each plot, each little one here contains 40 acres and measures how many miles on each side? Quarter mile by a quarter mile. You could put 1/4, or you could write 0.25. Either way. Quarter mile, quarter mile. All right, because we've broken it into 4 parts. Now this 2 quarters is a half. 2 halves is a whole, right? Okay, great job. All right, up here, top of page 45. Take a look at the next one. Use a ruler to complete the scale drawing of a square kilometer. The scale is 5 centimeters is 1 kilometer. And complete the sentences. I'm going to have to bring this a little closer to me. All right. Make tick marks every 0.5 centimeters along each side of the square. Oh my goodness. All right, centimeters. You're going to need to use the centimeter side of your ruler. I'm setting it here. 0.5 centimeters is right here. It's 5 millimeters. So, okay. And down the both sides. Okay, gosh. Hopefully my head doesn't get in the way here. So, here's 1/2. Next one, the next one, the next one. Hopefully I'm lining these up correctly. All right, there's one side. Down along each side. Oh my gosh, the whole thing. We'll go this way. Set your straight edge, your ruler up, whichever way is convenient for you. La-da-da, right? Okay, keep going. Down the sides, all of the sides. Here we are. .5 centimeters, which is basically 5, not basically, it is 5 millimeters. Okay. However you did yours is great. All right, done. Phew. All right. All right, then it says, then connect the tick marks to divide the square into how many small squares? Okay. How many small squares did we make? We made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we made 10 on this side. We made 10 on this side. 10 times 10 is 100 small squares. All right, I'll connect the connections and I'll be right back. All right, I've got my 100 small squares. It says the large square represents how many hectares? Okay, so when we were talking about kilometers, right? We have 1 kilometer by 1 kilometer. So if we look over here, it says there are 100 hectares in a square kilometer. A square kilometer is 1 by 1. So there are 100 hectares. And it represents that it represents land that measures blank meters on each side. 1 kilometer is 1,000 meters. All right, that's just how the metric system works. Each small square represents how many hectares? Okay, now there are 100 squares and 100 hectares, so each tiny square represents 1 hectare, and they represent land that measures how many meters on each side. Okay. 1 kilometer is 1,000 meters. There are 10 squares taking up this 1,000 meters, right? So 1,000 divided by 10 is 100 meters. So it's 100 meters by 100 meters. All right. Okay. So these are the main ones that they're going to be using for conversions, but this bit of information was helpful to answer the questions that they provided here. So you might want to keep this information handy. That's it for lesson 11. Go ahead and finish the We Remember, and meet me back here when you are ready for lesson 12. Lesson 12 begins on page 49, and it's titled Understanding Scientific Notation. Scientific notation is sometimes used to shorten very large numbers with many zeros, or very small numbers with many decimal places. And here are some examples. 4 times 10 to the 15th, very large number. 5.6 times 10 to the 9th, very large number. 3.8 times 10 to the negative third, very small number. Okay, remember the negatives tell us it's a smaller number. 1.067 times 10 to the negative fifth, very small number. Okay, to change a number from scientific notation to standard form, think of the power of 10 as telling you how many places and in which direction to move the decimal point. Positive, we're moving our decimal to the right. We're making it into a big number. Negative, we're moving our decimal to the left and we're making it into a smaller number. So 4, remember the decimal place is right here, times 10 to the 15th tells me I'm moving this decimal 15 places to the right, and it becomes this big old number. 5.6 times 10 to the 9th, I'm moving this decimal 9 places. Now, one of them is holding the 6, but the rest are going to be filled in with zeros, just like over here, right? All those places I moved, they can't just be left empty. We're going to fill them in with zeros. And the same goes here, except the difference here, right, is we're always going to have to move past the number first. So 3.8 times 10 to the negative third, I'm moving my decimal 3 places, but I'm only having to fill in 2 zeros because the 3 takes up one of those places. 1.067 times 10 to the negative fifth tells me I'm moving my decimal 5 places to the left, but I only have to fill in 4 zeros because the 1 that was there takes up one of those spaces. All right, so let's take a look at these. 4.5 times 10 to the negative fourth. You have to decide, is this number getting smaller or larger? The number is a very small number, okay? It's going to be decimals. 10 to the negative fourth. We're moving our decimal point to the left. 4 places. One of those places is going to be taken up by this 4. So I like to start them always like this. 0 point. It's going to be 0 point something. I need to move 4 places. Okay, so 4 places this way. 3 of those are going to be zeros. The 4 is taking up the 4th place, and then don't forget whatever else is left. So that is the number represented here. 7.06 times 10 to the 5th. Since I'm moving this time, it's positive, I'm moving my decimal to the right, I'm going to just start writing the number down. 7. Now, here's 1 decimal place, 2 decimal places, 3, 4, 5. Okay? I moved the decimal place 5 spots. 2 of those spots are taken up by numbers that were given to us, so 3 of those are just going to be zeros. Okay, 706,000. Number 2a, 2.13 times 10 to the third. The number is going to get bigger. It's a positive exponent. So 2 was already outside of my decimal, right? I'm moving it 3 places. There's a 1, there's a 3, and then 1 extra place. Okay, 1, 2, 3 places. If you need to draw the little swoops, draw them. Okay, nothing wrong with that. 4 times 10 to the negative 6. Negative 6 tells me this is going to be all decimal points, right? So I always like to write 1 or 0 point something. Now, 6 decimal places I'm going to be moving here from here to the left, right? 5 of them are going to be zeros because I have the 1, 4. So 1, 2, 3, 4, 5 zeros, and my 4 makes 6 spots, right? It was here. 1, 2, 3, 4, 5, 6 places. Always check yourself, okay? 3a, 5.63 times 10 to the negative 5th tells me I'm going to have only decimals, so 0 point something. I'm moving the decimal 5 places. 4 of those are going to be zeros, and the 5 is going to be the 5th. So 1, 2, 3, 4 zeros, my 5, and then my 6, 3 that were already behind the decimal are there. My decimal was here. 1, 2, 3, 4, 5. All right? Last one. 9.9 times 10 to the 10th. Oh my goodness. Okay. My 9 is already outside the decimal, so it stays. This is decimal number 1. Is that 9? 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. My decimal was here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. I moved it positive, so I moved them 10 spaces to the right. Okay? Positive exponent on your 10, you move your decimal to the right. Negative exponent on your 10, you move the decimal to the left. All right? That's your scientific notation. Go ahead and finish the We Remember and meet me back here when you're ready for Lesson 13. Lesson 13 begins on page 54, and it's titled Converting Between Celsius and Fahrenheit Temperatures. When discussing temperatures, it's important to know which temperature scale we are using. Here's a thermometer that has both a Fahrenheit and the Celsius. It says to change Celsius to Fahrenheit, we use this formula, that Fahrenheit equals 9/5 times C plus 32. To change from Fahrenheit to Celsius, we use that C, or Celsius, equals 5/9 times the quantity F minus 32, or Fahrenheit minus 32 degrees. Celsius degrees are larger than Fahrenheit degrees by a matter of 5/9, right? For every 5 degrees of Celsius scale, there are 9 degrees on the Fahrenheit scale, okay? They don't start at the same place, right? 0 degrees Fahrenheit is not 0 degrees Celsius, just like 0 degrees Celsius is not 0 degrees Fahrenheit, okay? And so then we have our conversions to make, okay? I'm going to do a couple of them. So there's a lot over here, so I'm not going to go through these examples specifically. I'll do a couple of them with the conversion here, but honestly, they gave you the thermometer, so you could just look at it and make the conversions that way. Like 5 degrees Celsius, right, is right here. And so that would be, what is this, scale of 2.5s, okay, 2.5, 5, 7.5. Oh no, 1, 2, 3, 4. No, it's a 2-point scale, so this is 42, 44, 46, 48, 50. So 5 degrees Celsius is here, and it is approximately, right, 41 degrees. But let's go ahead and look at these with our formulas, because you're not always going to have this thermometer sitting here ready for you. So 5 degrees Celsius, we can't just use a fractional conversion this time. We are going to have to use the formulas that they gave us. So we are starting with Celsius. So we are going to use, we're solving for Fahrenheit, right? So we use the Fahrenheit equals. So Fahrenheit, or F, is going to be equal to 9/5 times the degrees in Celsius, which is 5, plus 32. Okay, now this 5 here is basically like 5/5, okay, and therefore I have 9/5 times 5/5, so my 5s cancel with each other, and I'm left with 9/1, which is just 9, Okay, so I'm left with 9 plus 32, and 9 plus 32 is 41, which is what I said. 41 degrees Fahrenheit, right? Which we calculated from here. 68 degrees Fahrenheit is right here, is 20 degrees Celsius. Okay, that's my estimation. All right, but let's take a look at the formula. So we're solving for Celsius, so I want to use that formula. So Celsius is equal to 5 over 9. Make sure you're getting the right fraction, times the Fahrenheit, or 68 degrees, minus 32 degrees. All right, so 68 minus 32 is how much? If you said 36, you are the winner. All right, 36 and 9 can be reduced, okay? Basically, if you were putting this in your calculator, here, I'll write it out that way. If you're putting this in your calculator, it's 5 times 36 divided by 9. That's how you would put that into your calculator, okay? That is what's happening here, right? So because the 9 and the 36 have a factor in common, we can reduce that, though. There's 1 9 in 9, and there are 4 9s in 36. And so then you are left with, okay, if you aren't using your calculator, you are left with 5 times 4, which is 20. Which again, we just said that, okay? All right, 30 degrees Celsius into Fahrenheit. Okay, here's 30 degrees Celsius into Fahrenheit is what? 81 or 82, 84, oh, maybe like 85. But let's take a look. So Fahrenheit is equal to 9 over 5 times 30 degrees Celsius plus 32. Okay, 5 and 30 have a factor of 5 in common. 5 goes into 5 once, and 5 goes into 30 6 times. 9 times 6 is 54. So 54 plus 32 is equal to 86 degrees. Okay, so the conversion, not too bad. I'm going to do one more with you, and I will let you do the last two on your own. 77 degrees Fahrenheit is like right here, which is approximately 25 degrees Celsius, but let's do the math. Celsius is equal to 5/9 times 77 minus 32. Okay, we have 5/9 times 77 minus 32 is 45. Okay, 9 and 45 have a factor in common. That is the factor of 9. There's 1 9 and 9, and there are 5 9s in 45. So we end up with 5 times 5, or 25 degrees C. All right, okay. I will leave the last two for you to do the math with, or look at the thermometer here. But that's how we use our conversions from Fahrenheit to Celsius. All right, go ahead and finish the We Remember and the last two problems here, and meet me back here when you're ready for lesson 14. Lesson 14 begins on page 59, and it's titled Map Scales Using Proportions. Okay, on this map, because every map is different, 1 centimeter represents 100 kilometers. So that is the conversion factor that you would use to solve questions about this map. So looking at the problems here, it says, use proportions. Again, that's that formula that's weird. We're not doing that. And it says they want their measures to the nearest half a centimeter. So it is about how many kilometers from Edmonton to Calgary. Now remember, 1 centimeter, you're going to need a ruler with centimeters on it, okay? 1 centimeter is 100 kilometers. 1 centimeter equals 100 kilometers. All right, and we want to go from Edmonton, which is here, to Calgary, which is here. So how many centimeters is it? If I put my 0 on Edmonton, it is 3 centimeters to Calgary. So 3 centimeters to Calgary. My centimeters of my proportion go in the bottom, and therefore my kilometers go in the top. My centimeters cancel, and so it's going to be 3 times 100, or 300 kilometers. All right. Alberta is about how many kilometers from north to south? Okay, so Alberta is this whole territory. If I put my 0 at the top, I want to line it up as easily as possible. It's approximately 12 and what? 3 millimeters, 12 centimeters, 3 millimeters. So about 12 and a quarter. 12 and 1/4 centimeters. Okay. Changing this to a mixed number. Actually, I'm going to change it to a decimal this time. 12.25 centimeters. Okay. So 12.25 centimeters. And we put our centimeters in the denominator and our kilometers in the numerator. So my centimeters cancel. So I'm going to take 12.25 times 100, which basically means I'm moving my decimal 2 places to the right. So it's about 1,225 kilometers from the north to the south. All right. Medicine Hat, oh, where is that? Right here. Is about how many kilometers from Lethbridge? Oh, not very far. Let's take a look. We'll put our 0 on Medicine Hat. And we have about 1.5. So about 1.5 centimeters. So setting up our conversion again, our centimeters is going to be in the denominator. Our 100 kilometers is in the numerator. When we cancel, we're going to take 100 times 1.5. So it moves our decimal 2 places. So it's about 150 kilometers. Last question. It is about how many kilometers from Dawson's Creek, which is here, not even in Alberta, to Calgary, which is there. All right, I'm going to put my 0 on Dawson's Creek, and it is about 6.5 centimeters on my map. Setting up my conversion, my centimeters again are going to go in the denominator, so my kilometers here, and because I'm always dividing by 1, right, we can just kind of leave that 1 off. So I'm taking 6.5 times 100, move my decimal 2 places, so it's about 650 kilometers from Dawson's Creek to Calgary. All right. That's our conversion right here, 1 centimeter. And this map, now this is not a universal thing, right? Every map is different. Every map has a scale or a legend, and you would have to check it to be able to do the conversions properly. But for this specific map, that's our conversion. All right, let's turn the page because they've got a bit more on the next page. So at the top of page 60, it says, on the road map of Arkansas, the scale is 1/2 inch per 15 miles. It is 2.5 inches from Little Rock to Arkadelphia. That's a place, Arkadelphia, on the map. What is the actual distance? Okay, they solved it, and they got 75 miles from Little Rock to Arkadelphia. Put that on my bucket list here. All right, find the approximate distance in miles using the map scale of 1/2 inch equals 40 miles. So Harrison to Fort Smith is 2 inches. Okay. We have 2 inches is what we were given. Therefore, my inch is going to go in the denominator, right? And my miles in the numerator. 1/2 as a fraction can also be written, remember, as 0.5. So 1/2 is also 0.5. I'm just changing it to a decimal because for simplicity, okay? So 2 in our calculator, 2 times 40, our inches cancel, divided by 0.5, okay? 2 times 40 is 80, right? 80 divided by 1/2, or divided by 0.5, is 40. So it's 40 miles. because if half an inch is 40 miles, then 1 inch is equal to 80 miles, right? That's just the linear relationship between those things. So Little Rock to Harrison is 1.5 inches. So 1.5 inches, and our conversion is, we're going to use this one, 0.5 inches in the denominator and 40 miles. My inches cancel, right? So in my calculator, I have 1.5 times 40 divided by 0.5. Okay? 1.5 times 40 is how much? 60. Okay? Divided in half tells me it's 30 miles from Little Rock to Harrison. Okay? They think they're trying to dupe us, trying to trip us up with these conversions, but you guys have been doing this and you got it spot on. We're almost at the end of our math year, right? We're almost to book 10. You guys got this. This is no problem. Piece of cake. All right. Finish the We Remember for 14 and meet me back here when you're ready for lesson 15. Lesson 15 begins on page 63 and it is titled Complement of a Set. So, the members which are outside of a particular set are called the complement of the set. The symbol A prime, see that little check mark, means the complement of set A. So, the universal set are Mary's friends, Sarah, Renee, Julia, Sandy, Cindy. Group A, or set A, are the friends whose name begin with S. Therefore, the complement of that are all the peoples whose names don't begin with an S. A prime is what that's called. Okay? Let's turn the page. All right, the top of page 64. List the numbers in each set, then write the numbers that are the complements of set A and B. Okay. Number 1, the universal set are the numbers from 1 to 10. We're going to make our bracket, and we're literally going to write the numbers from 1 to 10. 5, 6, 7, 8, 9, and a 10. Close your bracket. All right. Set A is the factors of 10. Okay, remember the factors of 10 are numbers that multiply together to give us 10. So it's going to be 1 and 10. 1 times 10 is 10. 2 times 5 is 10. And actually, those are all the factors. 1, 2, 5, and 10, right? Because 3 times nothing gives us 10, 4 times nothing, so on and so forth. Okay, so A prime, the complement of set A, are all the other factors, right? So not the 1 and the 2, but definitely the 3, the 4, the 6, the 7, the 8, and the 9, right? Whatever was in the universal set that didn't land here lands as the complement of it. For number 4, the universal set are the even numbers from 1 to 10. Okay. So, even numbers from 1 to 10. 2, 4, 6, 8, 10. Right? Set B are the even numbers less than 5. So, 2 and 4. The complement, or B prime, is going to be everything else. 6, 8, and 10. All right? So complements are pretty basic, right? If it wasn't in the set, then it's the complement. It's everything else in the universal set. Now, this can't be said always for, or it can't be constructed easily for, let's say, all of the numbers that exist, right? Here's this one, all numbers. Set C are the numbers less than 100. So the C prime are the numbers that are greater than 100. Okay. These are the ones less than 100. So the universal set must be the numbers greater than, technically greater than or equal to 100. Since 100 wasn't included in set C, we want to include the 100, because otherwise then we got 100 sitting all by itself nowhere. Okay? So there's no way you could write them out like this, because you'd be writing forever, because the numbers go on and on forever. Amen. but you could write it like this, a little abbreviation. All right, so universal set, then we have a set inside of there. The complement to that set is everything that's not inside of there, but it's just part of the universal. Okay? And we write that with this little check mark. It's called the prime, C prime. All right, that's it for lesson 15. Go ahead and finish the remember, and you'll be ready for the test. As always, if you have any questions, please do not hesitate to contact me. Otherwise, until next time.